Okay, so another example. So that was pretty good, 2% at that bank for that certificate of deposit. We're gonna try something very similar. So a neighboring bank, we're gonna get a new deal. They want our business. Instead of getting interest once a year, the new deal is we're gonna get interest every month. So instead of waiting to the end of the year for my money to grow, it's going to grow every month. And I think that should be better if I get interest more often. Now, we'll have the same other information. So our principal, we're going to have $1,000 to invest. And we're going to go with an APR of 2% like before. Okay. Now, what does the A in APR stand for? Anybody remember? What is that A?
Future amount?
No, not in this case. A all by itself would be the future amount. Annual, yeah. In this case, A is annual. This is the yearly interest rate, okay? The A stands for annual. That means yearly. So at the end of each year, I get 2%. Now, I want to get interest each month. Now, it's not fair that they're going to give me 2% in the month because the 2% counts for a year. So the way the simple interest formula works is they had that PRT formula there. T is how much time has gone by. So if I'm calculating my interest amount, which is what the I is here, I would take my $1,000, I would multiply it by 2% as a decimal. Oops, missed a place there. 0.02. And then I have to multiply by how much time has gone by. Well, the easy answer to that is, well, there's 12 months in a year, so the easy thing to say is 1/12 of a year has gone by, okay? And if I clean just this part up right here, 200ths times 1/12, well, that could just be written as 0.02 over 12. Now on the calculator, that's a little messy, so sometimes I like to stick with fractions on this. So I'll just show you what I mean here. If I take 2% as a decimal, which is 200ths, and I divide that into 12 pieces, one for each month, which is the fair legal thing to do. There's actually laws about that. It's 0.0016666666. Now, you might think that just cutting off those sixes and rounding it is the way to go, but the bank might not want to round up too early. They might want to hold on to some of that to more carefully calculate the value. So usually what happens in a case like this is we don't prematurely round and call this 0.002 or 0.0017. We just use the whole thing. So we're going to stick with that fraction. So if you don't like fractions, I apologize. We're stuck with it for a little bit. But we have calculators, so it's not that bad. This fraction I wrote in red is the conversion from a yearly rate to a monthly rate, whereas the 2% is a yearly rate. This right here is a monthly rate. And so that's going to be my new rate for what I'm going to do here. So I'm going to make a table like before. Instead of years, I'm counting months. And then I want to look at what's my future amount. Yeah, we got to be careful. We have A for amount. We also have A for annual. So context matters. So we're going to start with a 0 like before, and we're going to have $1,000 to start with. And then 1 month goes by, and I apply the formula like before, which says your new amount is going to be that 1,000 times parentheses 1 plus your rate. And my rate is 0.02 over 12. And 1 month has gone by, so I just leave it like that. If you don't like the fraction, then there is an alternative. You could use some decimals. So maybe I would want to hold on to like 5 or 6 decimals to be safe. So if fractions are really freaking you out, get a spreadsheet, or you could do something like this and it'll be close enough. So, but I'm going to stick with the fraction for now, months, because I have a calculator that doesn't care if it's a fraction or a decimal. So I have 0, 1,000, and then 1 month later, it's going to be 1,000 times 1 plus, and my calculator said it was 0.00166. Maybe I could round over there if we wanted to keep track of 6 decimals. Nice thing about the decimal version is that cleans up pretty good because I can just easily add the 1 to that, whereas the other fraction version, it's harder to add the 1. Okay, so that's the decimal version. I'm here rounding to that 6th place. It'll probably work out fine. We'll look at that in a spreadsheet in just a moment. All right, let's go back to my other page with the fraction. So we have 2 ways to write it down, fraction or decimal. And we can plug this into a calculator. Now here's the key. You can plug that into a calculator exactly as you see it. Okay, so some of you on your homework and your exam, I've watched you do things like calculate this first and write it down, and then add 1 and write that down, and then multiply by 1,000. And that's a waste of time because calculators can do that in all one shot. So this is something you definitely want to practice. So I'm just going to type that pretty much like I see it into my calculator. You do it too, make sure we get the same answer. So let's clear this out. So I've got my 1,000 times parentheses 1 plus, and then I'm just going to type 0.02 over 12 and close the parentheses. Okay, so that's pretty much what I wrote on my paper. I used a fraction. Here it's using that funky division symbol. Same exact thing. Okay, so I hit enter, and the computer says you now have $1,001 and 0.666666 of a dollar. Okay, so that's around 67 cents. The bank would probably call it 67 cents, but we're going to hold on to that extra information for now. So I'm going to write the decimal version for now. So this is about, oops, I want a pen, please. There you are. About wavy equals, because I'm using the calculator's rounded version, $1,001 and about 67 cents. So that's my new amount. Now, what's going to happen is I'm going to repeat kind of the same thing that happened before, but I get this new amount there. So in year 2, I'm going to take that new amount. So this is an approximation, 001.67. I'm going to multiply by that same thing I have above. The bank's going to use this exact same calculation again. So times 1 plus 0.02 over 12. So I multiply that again, and I'm going to get my new amount. And maybe some of you are kind of getting to what's going to happen next. I'm just going to take that. It's already on the screen. I don't even have to worry about rounding it. I'm going to multiply by parentheses that same 1 plus 0.02 over 12. And I'm just going to keep doing that multiplication over and over again. Okay, so this time it's $1,003 and about 34 cents when we round it. So it's about $1,003.34. And depending on if you used a slightly different version of that number, like I had all the 6s my calculator would show, you might get a slightly different answer. So if I started with the $1,001.67 instead of the other version I had, and I multiply by that same parentheses super important here, without it, this does not work. 2% over 12, because there's 12 months in a year, still 34 cents. So get about the same thing, slightly different to the nearest thousandth of a dollar. But the key is I'm just going to keep repeating the same thing over and over again. So in the 3rd month, I'm going to have about that 1,003.34 from the previous step, but times that same parentheses, because that's what an interest calculation looks like. So can you see here that in each step, I'm repeatedly multiplying by the same thing? There, same thing here, same thing here. And what's another thing? What do we call repeated multiplication in math? Repeated multiplication is what?
that power?
Yeah, it's a power. So kind of a shortcut to these 3 steps I went through here would be to instead say, well, just, oops, switch to the pen, start with $1,000 and just take that crazy parentheses to the 3rd power. Okay, so we're gonna do this calculation both ways to double check it works. And that parentheses looked like this. So first I'm gonna do this part here, and then I'll ask the calculator to do that and see that they should be almost the same. There's gonna be some rounding error with my first way. The second way has less rounding error. All right, so calculator. So that was my $1,003.34. So let's just call it 1,000, oops, 334, and then multiply by that parenthesis, which is 1 plus 0.02 over 12, close parentheses, enter. So this version says I should have $1,005.01. I'm going to bring up another calculator. And type the exponent version. So that would be starting with $1,000, take that parentheses, 1 plus 0.02 over 12, close the parentheses, and then use the power button. That matters, right? Then the power gets to be 3. So just double check my notes, right? I close the parentheses because it's the parentheses, the whole parentheses that got repeated. So it's the parentheses that gets the 3rd power. And if I hit equals, I should get almost exactly the same thing as before. Now there's a little bit of rounding error because we rounded up 3 times in a row. Okay, so this is a slight overestimate of the amount in the bank, but to the nearest cent, it comes out to the same thing. That would get rounded to a 1. So this repeated multiplication by that 1 plus the rate gives us a new formula. So let's just summarize what we have, and then I'm going to set you guys free to collaborate on the lesson. So new page, summary. So summary of compound interest so far. And we're going to keep working on this. We're not done with it yet, but this is a start. First, we looked at yearly interest, so yearly compounding. And if it was yearly, we found that the future amount was equal to P times 1 plus the rate to the power however many years went by. For monthly, it's very similar. It looks a little bit different, but there is a pattern we'll look at the end of class. We started off with P, and we still have the 1 plus. Now we had to modify the rate by dividing by 12. The power, that's the big question. What is my power? Okay. It's not years in this second case. And oops, no, I want my other note page back here. In this case right here, that 3 I have over here. Come on, pen, where'd you go? Oh, there you are. That 3 as the power is the 3rd month. So in the second formula we have here, it's the number of months that have gone by. So I'm just going to actually write in the parentheses up here, oops, where's my pen? Months. In the problem above, it was the number of years that went by for the power. And if we were getting interest daily, which I don't know, did anybody, when you were looking up those certificates of deposit, did anyone come up with one that gave interest every day?
No, most of them were like
per year, I think.
Per year, yeah. I saw most of them were per year too. I found one that was months and one that was days when I went to some, what was it called? It was like cd.com or wegotthebestcd.com. I can't remember. Yeah, so sometimes you can get interest daily on investments. So instead of dividing by 12, so I'll just write that down what it looks like because we might do it later. We could collect interest daily, and that would look pretty similar. The future amount would be the present amount. And then we would have to take that yearly rate, R, and divide by the number of days in a year, 365. And then the power would be the total number of days that have gone by. So I'm just going to make a prediction about the month one and compare it to the yearly one. So let's go back a couple pages in the notes to see that. And so again, the 12 in the bottom of the red formula is 12 months. The 365 in the bottom of the daily formula is because there's 365 days in a year. And we're using those because the rates are always given as yearly rates. It's either what's called an annual percentage rate or an annual percentage yield. They're similar but different, but they all relate to a year, a whole year, not a part of a year. Okay, so did we ever calculate the 10-year amount? Let's do that. What happens if I take 1,000, so this is the yearly compounding, $1,000 here times that 2% raised to the 10th power for 10 years later. So calculator, choose this one. So 1,000 times, and here it was simple at 1.02, I didn't need parentheses, but I could have them, raised to the power 10. So this would be if I get interest 2% per year only. I would get $12,018.99. So $12,1899. Let's add that to the notes. All right, so that's down here in the bottom right. $12,018.99. And that one right there is 10 years later. If I collect interest every year. We're going to compare that to the monthly one next. So let's go to another slide down the road here. Oops, too many slides ahead. This one right here. All right, so let me see. This table right here is using months. How many months are there in 10 years? How many months have gone by if 10 years have gone by?
120.
120 months, yeah. So 10 years would be the same thing as 120 months. So that's the power we have to use in this case. It's just 10 times 12. So my formula is going to be for the 10th year, $1,000 times that 1 plus 0.02 over 12 to the power 120. So let's put that in a calculator and see how it differs from the other one. So the other one I had $1,218, almost $1,219. If I do monthly compounding, it'll be 1,000 times, this time the parentheses are essential, 1 plus 0.02 over 12 raised to the power 120. Okay, so that's what I had written on my note page. I can do it all in one shot. Enter. Now I get $1,221.20. Okay, so it is a little better, not a lot, but if I had more money to invest, I'd have more money in interest. Takes money to make money, they say. So this is 1,221, and then that would round to 20 cents. 1,221.20. So again, that's a little bit better, 2120, than in the previous one, which was 1899. Right down here at the bottom. Oops. Right there. Okay, so turns out we just did almost all of the lesson together. And so now you guys just got to go fill in some pages if you haven't already. So I'm going to set up some breakout rooms. We are now going to jump into lesson 4.1 online. And this is about investments. If you haven't already read that top part, you should. It's important. I've talked about most of it. In this first part here, they show the calculations we just did together. And then down here, we're jumping into some answers with exponents. So let's group up. I'm going to stop the share for a moment, stop the video.